Okay, so the purpose of this video is to go over a rule called Descartes' rule of signs. And Descartes' rule of signs helps you know how many positive real roots and how many negative real roots you have of a polynomial. So I've written it here on this slide, and I'll read it out loud to you. And if you haven't copied it down into your notes yet, you should go ahead and do that. Descartes' rule of signs says that the number of positive real roots of a polynomial p of x is equal to the number of sign changes between the terms, or is less than that by an even number. And the second part of it says that the number of negative real roots of a polynomial p of x is equal to the number of sign changes between the terms of p of negative x, or is less by an even number. So if you haven't written that down in your notes yet, you should pause the video and do so now. Okay, so Descartes' rule of signs is something that you'll probably use a lot more next year when you're in pre-cal, but I wanted to go ahead and introduce it to you since it's part of our Algebra 2 curriculum. So I'm going to give you a polynomial. Let's call this polynomial x to the third minus 4x squared minus 6x plus 7. And I might want to know, before I even started doing the synthetic division, how many roots I've got. So you know, first of all, you have 3 real roots. Sorry, back that up. We have 3 roots. And how do we know we have 3 roots? That's right, we have a third degree polynomial. So I may want to know whether the real roots here are positive or negative. And the way you should do that is with Descartes' rule of signs. So for positive roots, Descartes' rule of signs says the number of positive real roots is equal to the number of sign changes, or is less by an even number. So the first thing I'm going to do is look at this function I've got, polynomial, and I'm going to say how many sign changes do I have between the terms, meaning between consecutive terms when they're written in order as they are here, how many times do the coefficient signs change? So my coefficient on this first thing is 1, coefficient on the second one is -4. That is a sign change. Then between the next two terms it's -4 to -6. That is not a sign change. And then from -6 to 7, that is a sign change. So that means I have 2 sign changes. So the maximum number of positive real roots I could have could be 2. Now, I could have that many positive real roots, or I could have an even number less than that. The reason that the even number pops in, do you remember when we were talking about the complex conjugate theorem? That if a complex root appears and all the coefficients are real, its conjugate's also there. That basically means that complex roots occur in pairs. They always come in 2s if your coefficients are all real. So if some of the things that would loop down and actually give us positive roots are actually complex roots, though I would take 2 away from the total, and then I would have only 0 positive roots left. That's basically why this thing here says less by an even number. So if I had 3 sign changes, I would basically have 3 or 1 as possibilities. It always has to be an even number less. Okay, so now the second part, looking for the number of negative real roots, and that's equal to the number of sign changes in p of negative x. So the first thing I'm going to do is write p of negative x. And that means in the original polynomial, I'm going to replace every x with a negative x. I want to simplify this. So when I cube negative x, it'd be a negative x times a negative x times a negative x. So that would be a negative, because negative times a negative times a negative, x cubed. When I square negative x, that's going to give me positive x squared, but it's multiplied by -4. This -6 times negative x would be plus 6x, and then the plus 7 wouldn't change. And now I count the sign changes again. Here, no sign change. Here, there is a sign change. Here, no sign change. So for the negatives, I have 1 negative real root, and it would be even numbers less than that. But I can't take 2 away from 1. I get -1. I can't have -1 roots. So my only option is to have 1 negative real root. On the positive, I could have 2. If I had 2 positive real roots and 1 negative, there would be no complex roots. If I had 0 positive and 1 negative, there would be 2 complex roots. That's Descartes' rule of signs. Again, you count the number of sign changes in the original function. That's the maximum number of positive real roots, and all the other possible numbers are an even number less than that. And then for the negative one, you plug in negative x, you simplify that out, and you count the sign changes there, and that's the maximum number of negative real roots, or it could be an even number less than that.